Let's now continue our review of the z-test with this problem concerning fishing line and the breaking strength. The company claims a fishing line has a breaking strength of 8 kilograms with a standard deviation of a half kilogram. Consumer Reports tests 45 of these things. Let's see if the company's claim is indeed accurate. To get started on this, let's state the null and alternative hypotheses. So the null hypothesis will be that the company's claim is correct and that mu is equal to 8. For the alternative hypothesis, this is where reasonable people could disagree. You could think that the company might be overstating how good its fishing line is, in which case mu would be less than 8 for the alternative. Also equally valid would be assuming that the company was underselling itself so that it would be try to be overly honest, so that mu would be greater than 8 for the alternative. And if you have absolutely no which idea, then you'd have mu not equal to 8. So for this problem, I'll take mu to be not equal to 8 to cover the case that I really don't know which way it would go if there is a difference. Notice that this decision got made prior to actually finding out the average of these 45 numbers. To compute the average and then choose less than or greater than based on what the average happened to be is called data snooping, and that is not permissible. We make this decision based on our a priori feeling about which way the average would change before taking a look at the data itself. Okay, now we take alpha to be equal to 5%, and we compute the z-value. We have a decently large sample. Also, the standard deviation is given, so we can know the value of sigma. So x bar minus mu over sigma divided by the square root of n. Okay, so let's compute this. The average is equal to the average of these 45 numbers. So that's equal to 7.74. 7.74. So 7.74 goes here. Minus 8 divided by the known value of sigma, 0.5, divided by square root of n. Now it's important that sigma is known. If sigma was unknown, we would have to use the t-test, which we describe in other videos in this series. So let's compute the z-value. We get 7.74 minus 8 over 0.5 divided by the square root of 45. So negative 3.4883. So let's say negative 3.488 for the purposes of writing this down here. Pardon me. Okay, so that's the number I need. Let me bring that to the bottom of the screen. And let me get rid of this so I can draw the pictures for how we're going to determine whether to retain or reject the null hypothesis. The first way of deciding whether to retain or reject the null hypothesis is by figuring out the p-value, which means I need the area to the left of negative 3.488. However, because I had a two-sided alternative, because I had a not equal sign, when I wrote down the alternative hypothesis, I need the area from both the left and the right. So this has the practical effect of doubling the p-value. So the p-value would be equal to twice times norm s dist of the number that we just got. So the number I got was negative, so I find the area to the left of that, so that would be the norm s dist, then doubling would give me both of them. So for this particular problem, I would just simply take 2 times norm s dist, and I get the p-value of 0.000486. Now I'll let you think about what to do if the z-value came out to be positive, but it wouldn't be just simply doubling norm s dist. For this particular problem, that was what I needed to do. That's not what I have to do for all problems, depending on whether or not the z comes out positive or negative. I'll let you think about that. Okay, so that's the p-value. Now p is going to be less than alpha. Alpha will be 5% as usual. and so we will decide to reject the null hypothesis. The second way that this problem could be done, and I'll do that in red down here, is to figure out the critical values. And the critical values will be the values so that the total area that I'm about to shade, combining the left and the right, combines to be 5%, which means I need 2.5% on this side, and I also need 2.5% on this side. So there's a couple ways that the critical values could be found. So critical values, we could do norm S inv of 0.025. Cut the 0.05 in half, so that would be the left critical value, and that would give me negative 1.96 approximately. The other thing that could be done, which makes sense, would be to take 0.0975, so that 97.5% of the area lies to the left, and 2.5% of the area lies to the right. And this one, not surprisingly, would be positive 1.96. Now, clearly, I don't need to do both of those things. I just need to do one of them, and then the other one will be the negative of what we just found. So the critical values work out to be plus or minus 1.96. Okay, so there's the cutoffs. I reject if the critical value, or if the z-value falls in the rejection region. In this case it does. Negative 3.488 falls in the left rejection region. And so our decision is that we reject the null hypothesis. In words, it appears that the mean breaking strength is not 8 kilograms. Okay, so that is how to do this particular hypothesis testing problem using a two-tailed test.